Hey there, everyone, it's Alejandro, and welcome back for day 226 of me doing Daily LeetCode Challenge until I reach 1 year's worth of good contributions here on GitHub. So today's problem is for February 27th, 2025. And without further ado, let's get straight into it. Okay, today we get LeetCode medium problem 873, length of longest Fibonacci subsequence. A sequence x1, x2, xn is Fibonacci like if n greater or equal to 3, xi plus xi plus 1 is equal to xi plus 2 for all, okay. Oh, but I see, it doesn't necessarily have to start at 0 or anything. Okay. Given a strictly increasing array R of positive integers forming a sequence, return the length of the longest Fibonacci-like subsequence of R. If one does not exist, return 0. A subsequence is derived from another sequence R, but deleting any number of elements, including none from R, without changing the order. Yeah. For example, okay. What's the constraint on this? Okay, 1,000. Okay, so we can do n squared. Wait, that means for... Okay. Okay, yeah. The very first thing that jumps at me, first of all, is DP, right? It's talking about subsequences, it's talking about longest, which is an optimization problem, and so on. Fibonacci is a recursive, recurring pattern. Like, this just screams DP up the wazoo at me. Now, there's multiple options, right? Either you do for every single index I, you look at every single index j after your I, and you use those two as your base. Right? You use those two as your base because you need a base that's defined by two numbers, right? So maybe that's where the n squared part comes in. Okay, cool. If I do that, then once I have a base, I need longest, yeah. It needs to be with a specific offset. Yeah, can't add a base parameter. What are the values? They're up to 10 to the 9. Oh, it's sorted? Oh, it's a strictly increasing array. Okay, cool. Right. Yeah. Okay, so you want the longest. I mean, okay, this could also be like you do something for every single index I. It's like find the longest increasing or Fibonacci sequence from there. Yeah, it's weird, right? Because it's like you can't start at a single number. You need to start at two numbers. Interesting. All right. This does scream dynamic programming to me, but yeah, it's not going to be immediately obvious how to solve this. Okay. About 50% acceptance rate and no hints in case those were something that we needed. Okay. Interesting problem sets up. Yeah, so the problem is that we're going to need two numbers to essentially represent the base and the start of a Fibonacci sequence. Yeah. Interesting. This has to be recursive. It's just, yeah. I mean, DP is usually good for these types of things. If I have two numbers, right? If I have two indices, I can't do DP of... Ooh. I could do DP with an index and a base. Just there's up to... technically, there's only up to 1,000 bases because there's 1,000 numbers, or right, something like this. Def dp self and I in a base. Right here we'll do for I in range n is equal to length of r and I plus 1 comma n. To comma num in enumerate r. We'll call this num I of j. We'll just call it ri. Chain equals self.dp j plus 1 comma base 0 chain greater than 0 res equals max of res comma base plus 2 less than base plus 2 res equals base plus 2. Return res, right? Plus 2 for the first two numbers here. And because it says that n must be greater or equal to 3. We could also remove the if chain is greater than 0, just like if res is less than base plus 2. Res if res greater or equal to 3, else 0. Right? Something like that. Now dp, yeah, self of I and a base. So this is O of n squared work. Now if the total dp work happens to be O of n squared, right? It's just this one that worries me, right? Since the numbers can be up to 10 to the 9. But I gotta think about what my basis could be. My basis is gonna be, no, this is gonna be n squared number of unique possible bases, right? Or do I only need one number? First of all, we'll just put a cache decorator here. I greater equal to length of self.r n is equal to length of self.r. If I is greater or equal to n, turn 0. Otherwise, if of I plus base one plus self dot num equals self.r of I. If num is equal to base, right, the previous two numbers, then we'll do 1 plus self.dp at I plus 1, and base plus that number. Wait. Am I doing this wrong? We have bases x0 plus x1. We want it to be equal to this, right? Right, we want these two to be equal to that. Then yeah, we want these two to be equal to this. We want these two to be equal. Yeah, no, I'm not tripping. I'm not tripping. Otherwise, he would just return 0, right? Okay. Wrong answer. 17, geez. Okay, well that's definitely wrong. Jesus Christ, okay. Wait, what? How? Well that would be y. It'll be chain plus 2. Then res is equal to chain plus 2. Okay, here we get a wrong answer. Okay. So the memo of I. Else self.memo of I 0. Return self.memo of I. And yeah, self.memo equals this. Okay. And now all we gotta do is print what the self.memo looks like. Okay. All right, 3 0 2 1 5 0 4 1 7 0 6 1. So these represent my indices. So obviously the longest solution is from index 0. So from index 0, we haven't even given it the shot. Why is that? We haven't even given it the shot from index 1. Well, that would be why. So this will be all right. Maybe something like that. Not quite. And one would still be missing. How do I fix this issue? I just don't, right? Because I always have a chain of at least 2. Like, that's the problem. Yeah, all of these values are at most 1. Oh, well, first of all, there should be I comma base. And, okay, we're going to replace everywhere. Self.memo of I will become self.memo of I comma base. That's definitely something that needs to change. Right, geez, okay. But still, the max value is 1. So, we should have 1, 2, 3. So we should have index 2 with a sum of 3. Index 2 with a sum of 3. It thinks the longest sequence is 1. Why? Comma base plus num. That will be with a 3 plus this 3, which is 6. So 3 and 6. However, almighty my, I don't see a 3 and 6 anywhere here, which is very crazy. Do you guys? Oh, I do. 3 and 6, it thinks 0. Really now? Ah. Here's why. We're gonna do this for range. No, there's better than this. Self.dp of I plus 1 with just the base, and we don't add anything. Okay, 4 is better, 4 is better, 4 is progress. Okay, 3, 6 is equal to a 1 now. This is progress. If I is greater or equal to n, yes, this is good. Yeah, this was my bad right here. This was my bad. Actually, we'll say is equal to 0. Case 1 equals this. Case 2 equals this. Return max of case 1, case 2. Get rid of this. Zero if num, else this. It's the max of the two, right? Because keeping the base might give you better results. Okay, but that's still definitely a fix we needed. This will make things slow, but that's because we don't have a cache decorator. Although these problems are simple enough. Res equals this, self.memo of I, res, return res. Beautiful. Oh, and also this is I comma base, lol. Okay. And this should still be I comma base. Okay, now we're doing this. Okay, wow. Wow. All right, so here we should have 2, 3, 2, 3. Where's 2, 3 is equal to a 2 when it should be equal to a 3, right? Index 2 with a base of 3. This should map to 6, 3, 6, right? This is not equal, so it moves on. Then it moves on, right? So we should get to 6, 6, or 5, 6, 5, 5, 6. So I need a 5, 6 in here. Beautiful. So it thinks this guy's a 1. This should not be a 1 plus, right? Right, okay. I'm not stupid here. Plus 1 will be at 12. I see what's happening here. You're face to face with greatness and it's strange. I'm always doubling by 2. I'm not actually doing Fibonacci. Here I should be adding this instead of, oh gosh. Here I shouldn't be adding 6 or like, yeah. Here I should be adding 2, not 3. So I shouldn't be adding the prev num. It's like here I need to keep track of the previous index. Oh boy. Let's begin. I mean, it's fine if I do O of n squared call, O of n squared work where each call I make a DP call which has an O of n squared total complexity, and then everything just all works out to be O of n squared even though it looks cubic or quadratic. Or yeah, that would be fine. But if I do an IJ, maybe I do that, right? Where I have an IJ. Oh no, but then I can't do O of n work in there. Jeez. Open your eyes and let's begin. Or maybe it's like I have suffix counts. Right, maybe I create an array of like available numbers everywhere. It will be at most 1,000 in length. And squared work is it's totally fine. Suffix counts maybe. That way I always jump to the earliest index I need. Actually, that could work. Suffix frex. And reversed R. Num equals d dot get num 0 plus 1. Suffix frex dot append d dot copy. Suffix frex backwards, right? This is O of n and it's O of n iterations. This is O of n, so this is all O of n squared work in total. O of n squared. Right, there we go. That's completely fine. Now what we can do, suffix for x equals yeah, so the beginning is just, 8 with frequency 1, 8 and 7 both with frequency 1, 8, 7, and 6 with frequency 1, etc., yada, 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 right? Cool. Oh, wait, it's strictly increasing order. Since R is strictly increasing. Oh, wait, that's going to make this problem actually super trivial. This is the pivotal moment. Since R is strictly increasing, that means every number in R is unique. Hence, we can map each number to its index and use that whenever we need number in one of our DP calls. Okay, so here we'll say num2 index is equal to this. For I, num in enumerate R, cert num not in num index. Self.num to index. Right? Oh, well, how did I do that? Okay. And then, yeah, and then we can make DP something like just an index ij, right? So here we can just do def DP self, I, j. What we'll put a cache decorator here. Here we'll call this DP old. Then we'll do something like I is less than or equal to j. Base is equal to, what is base equal? Self.r of I plus self.r of j. Self.num to index.get base -1. Index is greater than j. And we'll return 1 plus self.dp index j, index. That's pretty much it. Are equal to length of self.r. Return 0. Return 0, maybe? And here, all we gotta do is return max of self.dp of I, j for I in range n, j in range I plus 1. N is equal to length of R. Self.r equals R. Plus 2. And yeah. Range n, range I plus 1, comma n. dp of I, comma j to include the I and j, right? This is also, yeah, this is also too smaller than it should be. Then return res if res greater equal to 3, else 0. Something like this. Okay, that's accepted in both cases. Let's submit. Did I put a cache on my DP? I did put a cache. Emily, really? I see. Interesting. Okay. We can use a self.memo, if anything. That way we don't have a bunch of zeros. If I, comma j, return 0, self.memo of I, comma j. Self.num to 1 plus self.dp of j comma index if index greater than j, else 0. Self.memo of I. Okay, we passed this one. A little wishy-wavy maybe. Okay, there we go. Completion rate 226 days. Consistency is key. See ya tomorrow. Okay, noise. Although, okay, people are doing this much faster than we are. And we were memory limit exceeding and so on. So maybe the way we're doing things isn't the expected way, but it's a way. So that's pretty nice and handy dandy. Okay. Let me get rid of that. Yep. Yeah, the very first thing I'll put is that. Res. Index greater than j. And plus self.dp of j comma index. There we go. Yeah, this is quite slow. Yeah, so we're at 4,000 milliseconds. Wow, that is kind of slow. Yeah, we don't need this stuff. Case is equal to, or length equals this. Res less than length, res equals length. We're also blowing up in this way. Oh no, this is not blowing up anything. Yeah, this is just fine. Yeah, I mean, this is just DP with I and J. How is my solution so slow? That's my real question. Huh. Okay, that shaved off 1,000 milliseconds. Cool. I guess it's O(n squared, but like, I can treat each of these DP calls as free. Right? Because I do O(n squared work in total from the DP calls. Maybe I could do numbers. Num1, num2. Because all the numbers are unique. Ah. And enumerate R. We can do things in terms of numbers. Yeah, we can just do x1 and x2, or x and y, comma x plus y. We can do x comma y, then we'll return x comma y. Delta r of -1. Yeah. We just have to check if the number exists. Self.nums is equal to set of r. If x plus y in self.nums is equals 1 plus self.dp of y comma x plus y. Like this. Oh, that's another reason why things were slow. Okay, let me do this. Let me copy all of this. That's another reason why things were slow. I wasn't doing that step properly. Let me get all the xy's out of the way here. Okay. Here there should be I comma j. Really? That's still not fast enough? And now I'm gonna memory limit exceed? Really? So by not having self.memos, there's no way this is fast enough. That's gotta be a joke. What? I see. That's crazy to me. Wow. I mean, damn. Okay. Like, it's like worst case up to, like, this is technically O of n cubed then. Wow. Okay. I need to make some serious reconformance. Okay. Wow. Jeez. Why? So this is 123 ms. I don't need this. Really now? So this is 4000 ms, but without this, you're telling me it's faster. Mate, this makes no sense. Okay. I mean, I understand why. It's gonna be like, you know, very, very infrequent. Mate, that's crazy to me. Okay, that is completely crazy to me. Okay. Wow. Do we even need this? Yeah, because the number just won't be in there, right? So it's a termination case. Jeez. And if I put a cache decorator, you're really telling me it's slower. It's so crazy. MLE. I'm stunned. I'm actually speechless. I mean, okay. I mean, no 0. That's pretty much it. And that gets me 40%. That's crazy. Like, this is technically n cubed work. It's technically n cubed. Oh, is it because every single situation is unique? Every single situation is unique. How many tests are there? 57? If every single situation is unique, no need for caching. Every single situation is unique. Therefore, total amount still be at merged error. No, but that's not true, right? There's many different summations. No, the specific... I'm not going to make that claim. I'm too scared of making that claim. For some reason... caching as per solution above makes things slower. Hence, return the raw results. Return this. Beautiful. There we go. Nice. We can get rid of this. Just keep a hash set of the numbers in R needed as its existence will be unique. Since array is also strictly increasing, search a number guaranteed later in the array, making a valid subsequence order-wise. Beautiful. N is equal to this. Actually, yeah. You can just do something like this. Set R or nums dp equals lambda I comma j or x comma y, and just this. Nice. You can recursively call a function set of a lambda. It's actually kind of beautiful. There you go. I mean, like, we're starting to get closer to that standard deviation. Wow. I mean, I guess that's kind of it, right? Supposed to equal to every solution starts with a valid comma 1 if res greater equal to 3, else 0, right? Because doing return res will get me a wrong solution, I would suppose, right? Because it could give me a length 2 solution somewhere. Exactly, which we don't want. Beautiful. And there we go. Okay. Wow. I mean, that's pretty much it. I'm just very surprised that caching ends up. Increment res by 2. Swipe pair. I mean, there we go. Beautiful. Okay. I mean, this is what I come up with. All right. 1110 ms beats 42.39%. We're kind of close to the standard deviation, and this is just what I thought of doing. It seems to work, so we'll just leave it at it. As always, in my recap, I do a quick recap if I was able to solve the problem, and I want to make sure that from now on I make my recaps actually quick instead of 30 minutes long. So essentially what I did is very quick. Quick recap of the problem. We want the length of the longest Fibonacci sequence. How is a Fibonacci sequence defined? It doesn't necessarily have to start at 0 and 1 like a traditional Fibonacci sequence. It can start at any two numbers as long as the sequence is greater or equal to 3 in length. And again, like the sum of the two previous numbers in the sequence, the sum of any number must equal to the sum of the previous two numbers, right? For x of I plus 2 must equal to x of I and x of I plus 1 added together, right? Just like a regular Fibonacci sequence, right? And the very first thing that came to my mind was dynamic programming, right? What I thought of is essentially this. We're given that the array is strictly increasing, which is something that we can utilize because that means that every single number is unique, right? Since every single number is unique, what I figured is I can map every single number to its index. Now, this isn't actually necessary, right? Because here's like, the idea was like, we're gonna start with we're gonna go through every single index I and j inside of the array. Take those two numbers as kind of our base foundation of our Fibonacci sequence, right? Let's say it's like, the numbers x and y. We'll add those x plus y together, and we'll treat that as like our new base. And then we want to check like, okay, is that sum equal to somewhere in the array, right? And we want to check that, like, the index of that number is greater than, the indices of the two numbers that we currently have. Well, since the array is always strictly increasing, and since all the numbers are positive, it'll always be the case that, like, when you take a sum, if it exists in the array, it existed somewhere later on in the array. So here in this problem, I only keep track of a hash set instead of mapping numbers to indices, right? Because if a sum exists of two positive numbers, it will occur later in the array because it's a strictly increasing array. And here I have a DP function that essentially doesn't use caching because for some reason caching will guarantee that a total of O of n squared work will be done for my DP function, right? Because it'll be like, x, y pairs that are taken in, which are numbers, but every number is unique, so it's like the same number as total number of indices. So it'll be a total of O of n squared work with caching. It's just that caching actually got me into memory limit exceeded issues, and it got my solution to be a little bit slower, so I ignored the caching part, which technically makes my asymptotic complexity a little bit worse, but it seems to be faster on LeetCode, so I was like, okay, let me remove caching, right? But the way this works is very, very simple. DP is defined as follows. It takes in two numbers x and y, right? For example, I could take in the numbers 1 and 2. And it'll say, like, okay, we have a hash set of all the numbers inside of an array. Well, we know that if we want to continue this sequence, right, it means 1 plus 2, it means that we need 3 as the next number, right? For example, 1 and 2, 3 must be the next number. So we'll check, okay, is 3 in the array? So in our set of numbers, right? So is x plus y inside of nums? And if that's true, then we'll do 1 plus the continuing the sequence, where instead of x and y, we now have y and x plus y, right? Because it's like here, it's like, okay, if we have 1 and 2, then we want to be at 2 and 3, right? The sum is what we were looking for, so we'll do x plus y, and then the previous, like, it'll always be like 1 and 2 were like first and second, right? Then when we get to 2 and 3, that means that 2 is the first and 3 is the second, which means that the old second becomes the new first, and like, the new number that was the sum of the previous two becomes the new second, right? In this case, instead of first and second, I have x and y, right? So if x plus y is in my number set, then I'll say, okay, we're going to increase our length by 1, and we're going to get the longest chain from now y is my first number and their sum as my second number, right? If I had 1 and 2 and I see, oh, okay, 3 is indeed in here, then the next part of my sequence will be like, I'm always doing a sliding window of length 2, right? So like kind of like this. So it's like if I had 1 and 2, then we'll have 2 and 3. If we had 2 and 3, then we'll have 3 and 5, right? And that's essentially kind of the process. DP of y and x plus y will be 2 and 3. The next number that we need is a 5, right? 5 doesn't indeed exist, so then we'll say 1 plus the longest chain where we have the numbers 3 and 5, right? Which will be 1 plus the longest chain where we have 5 and 8. And at 5 and 8 will finally terminate because 5 plus 8 is equal to 13 will not be in our hash set nums, right? In which case we'll return 0, but that way we'll have the 1 plus 1 plus 1 plus 1 ends up giving us, like, the array length of 3, and then like at the very end we'll just augment the resolution by 2 because we're considering x and y's, right? And this is exactly what I do. I'm just going to loop through every single index I, every single index j inside the array, and essentially take, okay, length is equal to dp of x and y, right? The longest chain starting with those two numbers, and if res is less than that length, then we update the rest of that length, right? Now, those lengths, remember, they always start with an x and y that we initially assume in here. So at the very end, I will augment res by 2 because every single length that we found never accounts for the first two numbers. So they all needed to do plus 2, but I can just take the max one out of all of them and then add 2, and then I'll have a valid result. And then there's one last caveat, which is that n must be greater or equal to 3. So that's why I check if res is greater or equal to 3, because if not, if the longest subsequence is not greater or equal to 3, then it's 0. Because this is one of the conditions. Otherwise, I return res if it's indeed greater or equal to 3, right? And that's pretty much it in terms of how I was able to do the problem. All the magic is inside of this function, which essentially just says, like, okay, let's get all the numbers into a hash set, and we're abusing the fact that this array is strictly increasing, meaning that the numbers are unique, and since the numbers are positive, whenever we take the sum of two numbers, we know that if that exists in the nums, it must occur later in the array, making it a valid subsequence, right? So we're really, really, really abusing that property of the problem in order to do this problem a little bit more efficiently, and that is how I was able to solve this in 11, 10 milliseconds, which, you know, close enough to the standard deviation. I wonder if my solution is actually what was expected to be done, right? Because the fact that I was memory limit exceeding with the cache decorator was kind of crazy to me, right? Whereas like with caching, you guarantee the time complexity is O(n squared. Without caching, maybe it is still O(n squared, but I don't want to write a proof yet to guarantee that, and I don't even know if that's guaranteed yet, right? But otherwise, that's pretty much it in terms of how I was able to do the problem, right? So loop through every single pair of indices, and for every single pair, it's like, okay, ask yourself, if I make those two numbers the first of my sequence, what's the longest sequence I could get from then on? Okay, well, grab the two indices at those, grab those two indices, grab the numbers at those two indices, and just start the chain, right? Make that your x and y, and then like, okay, take their sum. Is that in my number set? If so, then okay, like make y my new x, make x plus y my new y, and just continue from then on and on and on, find the longest chain, do that for every single pair of indices I and j, and there you go, take the max result, there you have it, you have a nice and efficient solution, and that is pretty much it. And yeah, but otherwise, that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I'd highly appreciate if you left a like or a comment, but otherwise, I'll catch you in the next one. So till then, ciao ciao, my friend. Bye-bye.